Alright everyone, this is my first YouTube tutorial. My name is Eli Fideli. I'm the owner and operator of my site HomebrewProcessors.net, where I discuss various electronics projects, iOS programming, general programming, pretty much the whole 9 yards in terms of computer science and embedded development. I also work with FPGAs, programmable gate arrays. Anyway, in this tutorial I'm going to be showing you how to implement a C++ library that uses an object. In this library we're going to be just creating a simple hello world object that does nothing more than print hello world to the screen a few times. That being said, let's get to it. The first part you want to look at is the header, the .h. This declares functions. It doesn't list the definitions. Basically, it makes known to the system that certain functions and certain parameters, properties of the object, exist, whereas the CPP, the library source, is what actually implements these. One of the hardest things about making libraries is understanding the concept of scope, because we're used to, in programming languages, scope being implicit. That is, it's kind of not declared anywhere, it's just a virtue of how you write your code. It's implemented via form, not in writing. There isn't a scope keyword in C++ that then you follow by something. We're used to things like this, where int I up here is declared within the scope of a for loop, and it can be used in the for loop, but if you attempt to utilize it elsewhere, then your compiler starts throwing shit. Basically, it has all these issues because it's out of scope. In fact, prior to C99, you cannot even declare a variable within a for loop. You had to declare it previous to above, and then set the value, set the condition, and set the modulus, the change within the loop. So in libraries we have three, actually four, but I'll discuss that in a while. Three major keywords that affect our scope of certain functions. These are public, private, and protected. Public is what people probably associate object methods with the most. A public method or a public parameter is a parameter that can be accessed by any file implementing the class. So for example, our main CPP, by declaring HelloWorldLibrary.h, we are allowed access to the HelloWorldObj constructor, which I'll get into in a while, the print method, and the print 4x method, which prints hello world to the screen X number of times, depending on whatever this int I argument is. Private functions are a bit harder to understand, and there's a very gray zone between private and protected, which mainly centers around programming style, which that isn't a subject I will be able to teach you. It's something you have to develop for yourself. A major portion of the difference boils down to how much license do you want to give other people that may extend your class. A private declaration on a function means that that function, that data type, that primitive, whatever, is only available for use internally in the class itself. Whereas protected is basically private with reservations. It specifies that, for example, our main function could not utilize a protected variable, but if we were to write a function that extended the functionality of HelloWorldObj. If we superclassed it or implemented something else, then it would have access. An example of this would be implementing the AES algorithm, the standard encryption cipher that the government uses. The AES algorithm has three major variants: AES 128, AES 196, I believe, and AES 256. These are all based on the so-called Rindall cipher, which vary based on a length of key on a number of steps. Basically, in the Rindall cipher, you have four processes: subbytes, subbytes. Then you have shift rows, mix columns, and then you have a fourth one, add round key. Now, these functions are internal, and these are sub-functions. That is, depending on the key size, you will iterate these functions a certain number of times in the form of a for loop. If you declare these functions private, it masks them. That is, if we were to declare those functions as private, we could use them internally for our own purposes. We could segregate that code from our encrypt and decrypt functions, or whatever you want to use. And we wouldn't have to worry about the person implementing our code scratching their head wondering what these strange functions are that only do a part of a process. It, in a certain way, private allows for programmers to have control over readability and have better versatility over how well read their code is, which readability of code is a big deal. That's the reason why I comment the hell out of my files, because come a month, 2 months, 6 months, a year, if I look at my code, I'm not going to know what it does. I comment so I can follow my own logic to the process. Anyway, the process gets a wrench thrown into it if you want to extend your so-called AES class into other key sizes, in which case you have other iterations. I'd have to check the cipher like implementation details, the standard, the FIPS 197 standard, I believe it is. But these functions are iterated either between 10 and 14 times on their own. So what you could do is you could declare these protected, which means that somebody wanting to implement their own variety of it, say you implement AES 128 and somebody wants to do the 256-bit key variety. If you declare these functions private, they would have to completely rewrite the code, or they would have to get access to your source code and copy paste, like so many programmers like to do. If you declare them protected, the superclass that implements your original class would have access to those variables, but they would still be masked. They would still be masked from the common user in main.cpp. That being said, I've probably said enough about scope. Let's get to it. You'll notice that these functions are prototypes. If you've done anything with C++ before, you most likely know what a prototype is. It's a succinct variety of your program code that basically declares the form, if you will, of the code, but it makes no reservation as to what the code actually does. it delegates that to the source. The header establishes a common linkage between your implementing function or implementing class, in this case main, and the library source through this file. Notice that in this function we also declare our own header. This is important. That being said, on a side note, you will notice the difference in declaration of the header. System functions use carets or angle brackets. These are files and headers located within the system repository on your computer, and those are generally not modifiable. Whereas user space functions, user space libraries that you write yourself typically use quotation marks. That being said, if you want to find where your system folder is and dump your custom header into it, header and source into it, you can use angle brackets, but that's, for our purposes, that's more trouble than it's worth. As far as the functions, there's not too much to see here. We have to declare ourselves explicitly within the function namespace standard, as well as declare IOStream, because our code here in our library is operating outside the confines of the std namespace. So that must be explicitly declared. I don't believe, if you know otherwise, you're free to prove me wrong in the comments. I don't believe you can declare, using namespace, blah blah blah, within a library. It is possible to write your own namespaces by implementing multiple classes of object and superclassing them, so to speak, under a namespace. So namespace, whatever, this is a namespace, implements HelloWorldObj, object blah 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 blah. This object, this method here, is of particular importance. I'm going to spend the rest of my time, less than 2 minutes remaining, since I don't know if YouTube still has its 15-minute restriction. This is of particular importance. This is called the constructor. It is a function that is called to basically tell the system to delegate memory space and assign memory positions to your object. And you'll notice the syntax is different. There's no return type, yet it modifies variables. There's no return type, but it accepts arguments. In this case, we choose just not to accept arguments at all. But the constructor is something that must be called before you can proceed to use a object's methods, because otherwise you're just going to get a bunch of nonsense from the compiler and stuff. It's more trouble than it's worth. Construct your function. As you see, there's not too much difference though when you actually get into your program code. It's same as declaring an integer, or whatnot. Again, I'm going to be posting this code to my GitHub. I'm probably going to follow this up with another video. If you have questions, or if you have concerns, if I didn't explain something that doesn't make sense, or if you want more elaboration, post in the comments. I will read them. I have nothing better to do with my time when I'm not developing apps. So yeah, that's it.